In yesterday's class, I have discussed about the inertia of rest and inertia of motion. What was the main cause of the situation which are happening in the examples in our daily life? So first of all, you have to remember, identify the initial stage of the object, whether it is at rest or in motion, and according to that, write the cause of the inertia. And in today's lecture, I am going to discuss about the inertia of direction. First of all, you will analyze few daily life examples of inertia of direction. Many times you have observed that in rainy season, if a vehicle is not having the mud guard with the tires, what is happening there? The mud is moving, this is the tire, and the mud is moving along the tangent. And if you are moving along a dusty area, what is happening there? In that dusty area, in the back side, suppose you are moving through a dusty area, what you observe on the back glass of your car, you are observing the dust. Why this is so? Because the tires are throwing the dust along the tangent. One more example, when you are sitting in your car and you are taking a very sharp turn towards the left hand side, what you have observed many times, you are falling in the outward direction. If you are having a left turn, then you are falling on the right hand side. So these examples are based on the inertia of direction. Let us discuss about the inertia of direction. First of all, write the definition of inertia of direction. According to the definition of inertia of direction, a body moving in a particular direction, tries to remain in original direction when some force is applied on it. Inertia is the property, hence you can write it as it is the inability of body to change its direction. Now, what are the examples of inertia of direction? Write down first example, according to which while taking a sharp turn of vehicle, what is happening there? The person falls in outward direction. It means when you are taking the left turn, you are falling towards right hand side, and when you are taking the turn towards the right hand side, then you are falling towards the left hand side. Note down it. Explanation of the example, why a person is falling outward while taking a sharp turn. The explanation of that question: this is due to inertia of direction, because while taking a turn, the part of the body in contact with car changes its direction changes its direction, but the upper part, but the upper part is with but, the part which is not in contact, but the upper part tries to remain at rest, remain at rest. Hence, the person falls outward. I think now it is clear to you people. Note it down. Next example, that is example 2. I'm writing the example in the question form. Mud guards are provided with tires of vehicles. Why this is so? We will write the explanation. First of all, you have to write the first line. This is most important. This is due to inertia of direction. When the tire is moving and the mud tries to move with tire, but tire changes the direction, due to which mud flies away tangentially. Hence, mud guards are provided. Note it down. Let us discuss some more examples. Related to daily life, and we will find which phenomena is responsible for those situations. Assume a car is moving on the road, and as well as a bus is moving aside the car. Both are moving with the same speed, and if the driver of both the vehicles, the driver of bus and the driver of the car, they decided to stop the car and they applies brake with the same amount, you can say the retardation of 3 meters per second. If they applies the brake, analyze the situation whether the bus or the car, they will stop at the same distance or they will stop at the different distance. You will observe that the car will be stopped in a lesser time and the bus will stop in a longer time. Why this is so? This is due to the cause. If the object is heavy, more force has to be applied. Effect is more. If the object is light, so less effect is required to stop the object. Similarly, if you are kicking a light cricket ball, it will travel the same distance. If it will travel the longer distance in comparison to a football which is kicked by the same force. Or you can say, if you are having, suppose here you are having, this is the window pane, this is of glass, and you are dropping a stone, light, a very small stone from a particular height, this window pane is not broken. But if you are dropping a heavy stone from the same height, if any object is dropped from the same height, its velocity is same because it is moving under gravity. If you are dropping from the same height a bigger stone you are dropping, what will happen? This window pane will be broken. Why this is so? Because the lighter object produces the lesser effect, or to move or to stop the lighter object, lesser effect is required. But for the heavy object, more effort is required, and the heavy object produces the more effect. So these phenomena are related with a very important term in physics, that is the linear momentum. Now I am going to discuss the linear momentum. First of all, the definition of linear momentum. Linear momentum. What do you mean by linear momentum? Write the definition in your notebooks. It is the quantity of matter. It is the quantity of motion possessed by a body. It is denoted by P, and mathematically we can write it as momentum. Linear momentum and momentum is the same thing, is equal to the product of mass and velocity. This is not the definition. Definition is this. So you can write P is equal to M into V, the product of mass and velocity. The SI unit of momentum is unit of mass is kilogram and unit of velocity is meter per second. So its unit is kilogram meter per second. Note it down. Let us solve one numerical. Find the change in linear momentum. Change in linear momentum of a motorcycle of 200 kg when its speed changes from 54 km per hour to 90 km per hour. So solution is, first of all, you have to find the momentum and write the values. What is given to you? Mass is 200 kg. It is in SI units. So convert the initial velocity 54 km per hour and the final velocity 90 km per hour into meter per second. So directly you can do it, multiply it with by 5 by 18. It is 3 this is 15 meter per second, and similarly here 90 into 5 by 18, it in 5 25 meter per second. So change in momentum is what? Let us assume that P1 is the initial momentum and formula will be mass into velocity, initial velocity, and P2 is final momentum. Final momentum is mass into final velocity. So what will be the change in momentum? So change in momentum is P2 minus P1. This is mass into V2 minus mass into V1. So take 200 common, V2 minus V1. What is the value of V2? V2 is 25 minus 15. This is 10. This is 200 into 10. The change in linear momentum is 2000 kilogram meter per second. Note down. After this numerical, this topic of linear momentum has been completed. In the next class, we will discuss about the Newton's second law of motion, which is related with the linear momentum. Note down and learn these notes.